Hi, this is Richard C. I'm a math tutor at Wyzant, and we're going to be solving another question that was submitted by a student. And just have to adjust this text here 1 second so you can see it. Here we go. So this question has to do with a function, and I have to write the function in here. So it's a piecewise function. This thing keeps moving. Okay. Hopefully that'll do the job. So the function is f of x. It's a piecewise function, and it equals 3x minus 1 when x is less than 1. And it equals x plus 1 when x is greater than or equal to 1. And we have to decide whether it's continuous and differentiable. Basically, yes or no on continuous, yes or no on differentiable. So what I like to do is, on a problem like this, is always start with the graph. So when x is 1, we have the line x, the y value would be 2 here. And so when x is bigger than 1, we're going to have a graph of a line that goes like that. So that's the x plus 1 graph. And then when x is less than 1, when x is 0, y is negative 1 here. So put a 1 here. And then this graph is going to go down like this. So that's x plus 1. I'm sorry, 3x minus 1. Okay, so for continuity, there's an intuitive way to do this first, which I think is important. And then we have a formal math way of proving that something is continuous, function is continuous. The simple way, intuitive way, is to just ask yourself, can I draw a graph of this without my pencil leaving the paper? And the answer here is yes. So you should assume, or not, maybe not assume, but suspect that this is continuous. What we have to do for continuity, there's 3 parts. First question is, because we're wondering if it's continuous at 1 here. And so we have to find out whether f of 1 is defined. And it is defined. And you can see that f of 1 is equal to 2 here. And then we have to look at the left-hand limit as the limit as x approaches 1 from the left of f of x. And I think you can see that as you move along this part of the graph, you're getting closer and closer to 2. And then the last part we have to show is that the right-hand limit. Oh, sorry. This part is supposed to be the two-sided limit. Excuse me. But I think maybe the easiest way to do the two-sided limit here is just to, if you have the left-hand limit and the right-hand limit agree, then the two-sided limit exists. So the right-sided limit of f of x as x approaches 1 from the right, this is 2. So the limit, so the two-sided limit, the limit as x approaches 1 of f of x is equal to 2. And then the only other thing that we have to prove on continuity anyway is whether f of x, the limit as x approaches 1 of f of x equals f of 1. And f of 1 is 2, so we have 2 equals 2. So it's definitely continuous. So we can eliminate these answer choices. These are no good here. Now for differentiable, there's another just good intuitive way of looking at a graph and trying to figure out whether something is differentiable. And basically, you just want to think about the slope of the tangent line here. You can see, because this is a straight line, the tangent line obviously is the line itself, and it has a slope of 3. So the slope of the tangent line on this side of the graph is 3. The slope of the tangent line on this side of the graph is 1, because the slope is 1 here. And so because the slope does not equal that slope, it's not going to be differentiable here at this point. Basically, when you're looking for differentiability, you're looking for corners typically, and you have to test the slope of the tangent line from the left and from the right. Sometimes you come across functions that are waggling up and down like infinitely fast, and that's a different case. But usually you're looking at corner points. So once again, now we're just going to go through the similar test for differentiability. So, and it's the same idea really. We're going to, for part A, we'll look at the limit as x approaches 1 from the left of f of x. Oops. So you can think of this as f prime of x. You recognize this, I'm sure, as you can recognize this right away as the definition of the slope of the tangent line at a point f of x minus f of c over x minus c. You've seen this difference quotient, it's called, and you've seen this over and over in school. So let's just plug in here from the left, because we're coming from the left, so it's going to be 3x minus 1. And then minus, I need the limit here, of course. And then minus f of 1, which is going to be 2 over x minus 2. So this is the limit of, as x approaches 1 from the left, of 3x minus 3 over, oh, sorry, I don't know why I wrote a 2 there. Not x minus 2, x, c is 1 here, over 1. And then you can see that this is the limit x approaches 1 from the left of 3 times x minus 1 over x minus 1. The x minus 1's cancel, and you're going to get 3. Now let's do the right-hand limit, or in other words, the right hand. You could think of it as the right-hand derivative, because this quotient, this difference quotient is the way we find derivatives, as I'm sure you know by now. So let's see about the other side. As x approaches 1 from the right, f of x minus f of c over x minus c. Well, in this case, it's 1 for c, but let's keep going. So LIM, x approaches 1 from the right. So if we're approaching from the right, it's going to be the x plus 1 minus 2, because f of 1 is 2, and then x minus 1 down here. So this is going to be the limit. X approaches 1 from the right of x minus 1 over x minus 1. So this is going to be 1. We knew all this already just from looking at the graph. But unfortunately, when you're writing out an answer, it's not enough to just write a sentence saying, oh, I looked at the graph and this is the way it should be. Unfortunately, we have to write out follow these formal rules for continuity, which is on the top here, and then the formal rules for differentiability. And so we can see that it's not differentiable. And so we can eliminate this one, and our answer is the second option here. So that's it for this question. I wish you luck in your travels through calculus, and I'll see you again some other time, hopefully soon. Bye.